A very good morning. Myself Deepika from third year biomedical engineering. I'm going to present a title Deep Learning for Skin Cancer Detection, which the title is taken from the subject Fundamentals of Health Analytics. And here's my first slide, which is Introduction to Skin Cancer. So, skin cancer is the most diagnostic cancer globally, with millions of new cases annually. And melanoma is the deadliest from making up a small fraction of cases but majority of deaths. So, as well as survival rates exceeds 95% when detected in the early stages. So, as compared to traditional methods, relies on the ABCD rule, which is asymmetric, border, color, and diametric. And there is a global shortage of dermatologists, leading to long wait times for screening. And here's my second slide, which is limitations of manual diagnostics. So in this slide, I'm going to tell that visual diagnostic is a highly subjective and depends heavily on a clinical experiences. Even expert dermatologist shows significant inter-observer as in the diagnostics. Distance between binging molds and early stage melanoma is visually challenging, and diagnostic methods are invasive, expensive, and often result in negative finding. And human factive or cognitive basis and can lead to missed lesions during fully body scans. So the third title is the rise of artificial intelligence in medicine. AI has transitioned from rule-based system to data-driven deep learning method, and modern methods which can be now more match or exceed dermatologist performing image sets. So computer aided diagnostic can act as a digital triage system for high risk patients, and AI involves at home monitoring via for smartphones app, increasing accessibility. Integration of AI reduces the burden on healthcare systems by filtering out clear binging cases. So and the next slide is key objective of DL in dermatologists. So here's the classification, which is categorizing a lesson. Example: binging versus malignant. So after classification, we are seeing about segmentation. Segmentation is precisely mapping the boundaries and area of skin lesions. So detection, identifying the presence of lesion with the largest clinical image, and prognosis, predicting the likely prognosis of or severity of the disease. And standardization, providing an object data backed second opinion for doctors. And why deep learning over traditional machine learning? So end-to-end learning, DL skips the need for manual handcrafted feature engineering, and model automatically learns simple edges and then structure the complications, shaping and non-linearity compare, better capturing the subtle and coordinate patients for skin cells. So and the fourth sliders, which is understanding skin image modalities. So in this we are going to see about clinical image, dermoscopy, histopathology, and multispectral imaging, and finally total body photography. These are the four main major image modalities, which clinical image standards helps to standard photos. Dermoscopy helps in specialized polarized light imaging, and histopathology microscopy gold standard. Total body is high resolution maps. And the next slide is major database, public database, which is uh, ISIC achieved the National Skin Imaging Collaboration, and the next is HAMI 1000 benchmarks dataset containing 10,015 dermoscopic images across 7 classes. Next is PH2 dataset, which is a small high quality set focused on clinical dermoscopic, and BCN 2000 sorry, 20,000 a dataset from Barcelona focusing on difficult to diagnose lesions. So, and then is PAD UFES 20, a rare dataset focusing especially on smartphones. The next slide is data pre-processing techniques. So, data pre-processing technique is of resizing, dull tracer algorithm, and color normalization, and then is a cropping method, and finally contrast enhancement. In resizing, it helps to standardizing various image dimension to fit model inputs, and in dull tracers it helps to specialized technique used to digital remove air from image, and color is correcting the variation in lighting. Cropping means centralizing the lesions and removing peripheral noise. So the next slide is the challenge of class imbalance. So in Benjamin Wesley outcome number malignant cases in real world, and then overslamping is a duplicating rare image which helps to imbalance and training set, and then synthetic generation which helps to using the GNAs and fake but realistic images for rare cancer. Then we are going to see about data augmentation strategies. In this, we are going to see about geometric, randomly rotating, flipping, and zooming image, and photometric is altering brightness, saturation, and used to stimulate different lighting. And then is elastic deformation, mimicking the way skin textures are compressing during imaging. And then is our cutout dropout, randomly occurring paths, the image which focuses for the model to learn multiple cues. And the next slide is convolution neural networks, the foundational architecture for image which based deep learning tasks, and convolution layers use filters to detect edges, colors, and textures. Pooling layers is the reduced spatial size of data which saves computations. Activation functions which introduce nonlinearity to learn complex patterns. The next is ResNet, residual learning. Introduce skip connection to allow gradient and solve the vanishing gradient problem found in older deep archive architectures. Allows model to be 50, 101, 101, or even 152 layers. Extremely effective at capturing the fine-grained detailed of skin textures. The most common baseline is model used in modern skin cancer research. So the next is inscription and the efficient net. And the inscription which models look at the image with different scales stimulatively, and ideal for mobile based skin apps due to the computational efficiency. This model focuses on the maximizing information extraction in the limited pixels. And the next slide is transferring learning, the key to success. So training a medical model from a scratch requires millions of image which don't exist. And pre-training means models are first trained and on ImageNet. Next, fine tuning means retrained to the smaller set of skin cancer. This allows the model to leverage general and significantly reduces the training time and improves accuracy. And then is vision transformers, with a newer architecture that moves away from the traditional convolution, uses self-attention to understand the relationship between distinct parts of the image, and consider as the current state of the art for many medical imaging benchmarks. Lesion segmentation. Segmentation involves labeling over every single pixels as a lesion or a healthy skin. Unit U-shapes architecture designed specifically for a medical image masks. Multitasking learning models that segment and classifies often perform better. So generative adversarial network means GAN consists two networks. One is a generator and another one is discriminator, used to generate digitally synthetic image to expand the data set. It helps in training models to offset against noise or artifact. And explainable Clinicians needs to know why models made specific prediction and as well as highlighting the itself that most influenced in the AI detection and using heat maps to show if the AI is looking at the section of a random error. Transparency is a legal requirement in many medical AI regulations. The next slide is quantification. AI models can be confidently wrong and out of distribution, identifying when an image is not an lesson or to all. And the next slide is the bias and diversity problem. So models trained on these sets often show significant drop in accuracy for darker skin tones. So algorithm must be audited specifically for performance across all skin types. So future research require global data. Next is integration. Clinical integration means an AI model which is useless does not fit into a doctor's daily routine. So the human in the loop which approaches AI assist, but the human makes the final call. So in real time augmentation reality dermoscopy for instant feedback during exams. The next slide is regulatory and ethical hurdles. FDA CE certification or the pass rigorous clinical trials to make the medical devices and also the data privacy which ensuring patient information or stored and processed securely. Accessibility ensuring AI tools are affordable and for rural clinical and development nations. So the next slide is edging AI and in mobile health, moving AI from cloud and model pruning on device processing enables daily dermatologists real-time video analysis, scanning the skin in 3D using the phone cameras. And the future direction is federated learnings, foundation models, self-supervised learning, and deep learning is an augmentator. The fine ultimate goals are the future directions we are enabled here. The conclusion of this title is deep learning has transformed skin cancer detection from a subjective visual care which is into a data driven science by utilizing architecture like CNN or visual transmitter. So however the future of the field depends on a bridging the diversity gap by training on inclusive datasets that represent the all skin tones. So these are the title we so these are the content which I taken for my presentation. So these are about my topic. Thank you.